In this presentation, we'll be taking a look at NX CAD hidden gems. For a quick look at our agenda, the first item we'll be covering today is going to be measuring the interior volumes of your parts. We're going to take a look at some different techniques using some different feature operations inside of the NX software to help you with measuring those interior volumes on your designs. The second item we'll be taking a look at is assemblies related. We'll be looking at some snap placement functionality in conjunction with component interfaces inside your components. All right, our first topic we'll take a look at here is measuring interior volumes of our parts. So we'll take a look at how to measure the interior volumes on your parts and also creating live measurements of the interior volume, mass, etc. here inside your designs. So how can we quickly find the interior volumes on these parts? We can use a combination of features inside of our NX software. The interior volumes of our parts can be measured by using some different techniques here. Additionally, a live measurement can be created that will be updated based on your model changes. Now we'll take a quick look at the process here and then we'll jump over to the software to demonstrate using this process to grab the volume of our part, the interior volume, and then take a live measurement on our part. All right, so the process would start with extracting some geometry. We want to extract a copy of the original design body. We're going to do something else inside the dialog for the copy of the body. We're going to turn off the Fix at Current Timestamp option here. When we get to that point in the demonstration, I'll explain what Fix at Current Timestamp is going to do for you. And by turning this off, what that's going to enable here inside your design. Next, we'll take a look at using some synchronous delete face commands. And we're going to take a look at a selection rule here, and we're going to use the boss or pocket faces to quickly select our interior surfaces of our part. We're also going to use an option called all but selected here to help us with selecting or isolating the interior faces when we want to use the delete face command here. We'll show where that's at inside the software. You'll have to add that to your top border bar, and I will show you how to do that inside the demonstration over in the software. We're also going to take a look at the option called Turn On Heal option here. So we want to turn on the healing, and when we get over to the demonstration, I'll explain why we're turning this on and what that's going to enable the software to do when you use the delete face command. Next, we'll take a look at creating associated measurements with the interior volume here. Once we start to take measurements, we'll take a measurement of the extracted body, the interior volume here, and we'll also disable the Fix at Current Timestamp. We'll take a look at how to save that measurement associatively. And once we do that, with Fix at Current Timestamp turned off, we'll take a look at the live measurement aspect that we're talking about here. All right, so jumping back over to the software, we'll get into our NX software here. And now we'll go ahead and take a look at our particular part we want to focus on here. So inside this assembly here, we have a simple pump assembly. And I'm going to focus on this crankcase here. So I'm going to right click on that crankcase. I'm going to open that up in its own window here. And we'll begin focusing on the crankcase. So we want to find the interior volume of this crankcase. This is a simple example, but these techniques can be used on much more complex examples or designs inside your part here. The first thing we want to do here is go up and go to the Home tab, go over to the Base group here, and then we're going to go to the More dropdown. So on that More dropdown, we're going to go into the Copy group here and choose the Extract Geometry option. All right, so on the Extract Geometry option, we want to go ahead and select the body to extract. So we want to pick our original design. Now, Fix at Current Timestamp here is turned off, and that's what we want. What Fix at Current Timestamp is going to do, if that was turned on, it's essentially going to extract this body and save it at the exact timestamp in history inside the Part Navigator. If I turn off Fix at Current Timestamp, what that's telling the software to do is take a copy of this body, and it's going to allow it to update if I make any changes to the original body. So Fix at Current Timestamp, we want to leave that turned off for this technique to work. So I'm going to go ahead and select OK here. If we look at the Part Navigator and we scroll to the bottom here, you're going to see we do have our extracted body now, and that is sitting in the same space as the original design body. So right now we're going to go ahead and hide the original body. So I'm going to go back up to this extrude feature. I'm going to click on the hide icon here and just go ahead and hide that. Now that I have that hidden, we're focusing on the extracted body here. I'm going to go into my view operation here, and let's go ahead and change the color of that to make it easier to differentiate that from the original body. So I'm going to pick the body here, select OK. We're going to go into the color settings here, and we're going to go ahead and set this to purple and then select OK again. OK one more time. Now we can see that extracted body is purple. The next thing we're going to look at here is an item that's currently not on my toolbar here. If I look at the toolbar, the top border bar here just above the graphics display, you're going to see I have a couple of icons up here, but there's another icon I need to add that's going to help me with selecting some faces on my part. I'm going to go over to the right hand side. I'm going to hit the top, the border bar option drop down here. Go into the selection group. Once you put your cursor on that selection group topic, it's going to open up the subcategory menu here. And down below, we're going to travel down to an item called All But Selected here. So I'm going to go ahead and check that, activate that, and add that to my top border bar. Now you can see the All But Selected is up there on the top border bar. Right now it's grayed out because we're not creating a feature and we're not selecting any items inside the graphics display on our part. Once we start doing that, this is going to have a color icon here, and we'll be able to use that icon when we need to do that. So going into our next step now, we want to go ahead and go up to the Home tab, go over to Synchronous Modeling, and we want to choose the Delete option here. Once we open up the Delete Face command, on the drop down here, we want to make sure that we choose the Face option. So I'm going to select Face here. By default, the Face option is the default option inside this dialog, but I just wanted to show what that looked like on the drop down, and we're going to select the Face option here. So once we select that face option, we're going to go over to the right-hand side here inside of our graphics display. At the very top of the graphics display, we have our face rule dropdown. Now, by default, this might be set to single face, but we want to hit the dropdown. We want to choose something called boss or pocket faces here. So the software is going to look for boss or pocket faces, whether I pick this interior cylindrical face here, it's going to try and find all the interior pocket faces. If I were to pick an exterior face here, it's going to look for related or boss faces here based on the face that was chosen. In this case, I want to pick the interior pocket, so I'm going to put my cursor over this inside cylindrical wall, left mouse button click, and the software finds the interior pocket faces for me. Now, if I rotate this around, you can see it did find, we have some hole faces here with a chamfer at the top. We have a hole opening here as well, and then we have our interior faces inside our crankcase here. The next thing we're going to look at down below is an item called Heal. Now, when Heal is turned on, what the software is going to do is it's going to try and heal or close the openings on the selected faces here. If I turn on the preview mode here, with Heal turned on, you can see it's capping the openings, deleting those faces and capping the openings on my design, so I have a solid body when this is done deleting those faces. If I turn off the Heal option here, you can see it's going to delete those interior faces and leave behind a sheet body in my design here. So with the Heal option turned on, the software is going to close the openings to maintain a solid body condition or create a solid body condition after those faces are deleted here. All right, so that is Heal, the Heal setting here. Make sure that's turned on. Next thing we're going to do is now we're going to go up to our top border bar and we're going to choose the All But Selected option here. Once I select the All But Selected option, it's going to reverse pick or reverse select all the faces that were not previously selected and deselect the originally selected faces. So we basically did a reverse pick here inside of our design. If we look at that, what's left behind is the interior volume. Now we definitely want to make sure we have Heal turned on. If I turn off Heal, it's going to leave those openings and we have a sheet body that's going to be left behind. So we want to go ahead and cap that off. So we're going to make sure Heal is turned on here and we'll go ahead and select OK. Now the resulting geometry left behind is the interior volume. This is our target volume that we want to go ahead and be able to measure later on. Jumping down at the bottom here, you can see there's our extracted body. There's our delete face operation, and we're left behind with the interior volume. Now we can go up to our analysis tab. We can go over to the measure tool here. Open up the measure tool. I'm going to go ahead and reset that dialog, get back to its defaults. And now with the measure tool open, we're going to use the object radio button, activate that, and I'm going to come over here and select. I'm going to leave my my cursor there and let the quick pick show up. I'm going to left mouse button down once I see those three dots there. And then scroll down that list and choose the solid body of the extracted body. Once I do that, the measure dialog that opens up here is going to give me all the mass properties related to that solid body. The one we want to focus on here is the volume. So I'm going to come over here and I'm going to make sure I save this associatively. So I'm going to click on that diskette button there. And then over inside the dialog, you can also save your measurements associatively here. The difference is if I check the box here and have a check inside that box, it's going to save all of those mass properties associatively. Well, we don't want that, right? So we only want the volume here. I'm going to uncheck that, go back up to the volume here, and then just click on the save icon here to save that measurement associatively. I also want to display the measurement when I finish with this operation. So I'm going to click on the icon to display the measurement here. And over in the settings category inside the measure dialog box, we're going to go down here and there's a fix at current timestamp also here. So we want to turn that off. When we turn that off, remember this measurement will now be a live measurement because it is always going to continuously update inside our part. When you turn off fix at current timestamp, you're essentially telling the software that this measurement is going to be updating as I make changes inside this design. If I leave fix at current timestamp turned on and I were to create that measurement, if I were to add any additional geometry to this body or subtract geometry or Boolean operations to subtract geometry from that body, that measurement will not be updating for me. So we want to make sure we turn off fix at current timestamp so it updates every time I make a modification to my design. Now we'll go back in and select OK. Here's my measurement, approximately 339 cubic inches for this volume. And I'm going to go back and turn on the original body. So there's my original body, my original design body. Here's the interior volume that we extracted and then use the delete face command on to leave behind the interior. And now we have our measurement of that interior volume. There's a couple other things to look at here in relation to this topic. When you do extract this geometry, you've just added additional mass or solid geometry inside this part file. When you go up to the Assemblies tab and go over to the reference sets, the model reference set now includes that extracted geometry. The important thing here to remember is you want to remove this from the model reference set because that model reference set is utilizing all the geometry by default that's created inside the software, and that gets added automatically to the model reference set. The problem with this is that now that this extracted geometry is added to that model reference set, we're also affecting the mass properties on this part. So I want to remove this interior geometry that we extracted, hold my shift key down and left mouse button click that and remove that from the model reference set here. Once we remove that from the model reference set, the mass properties for this part will only be including the red geometry here. Now, if we go up to File, go into Properties here, and then we look at the mass properties here. So if you go into this Display Properties dialog, on the Mass tab, you're going to see a mass right now. It currently says no mass data is available, and that's because we have not updated our mass properties yet. If I want to update the mass properties, I can click on this button here, and I can see that this is approximately 30 pounds. We can also tell the software to update the mass properties on save here, so every time this file is saved, it's going to update this value as well. So it's going to rerun the mass properties, and it's going to give me that mass up here with the updated variable. So I'm going to go ahead and select OK. If I were to go back into the assemblies, reference sets, go into the model reference set and add that back in, and then close this, let's go back into File, Properties, and take a look at our mass properties when we update them. Now you can see this part is much heavier. So this is the reason why you want to make sure you remove that extracted body from the reference set, the model reference set inside this part file, because that extracted body is automatically added to that model reference set once it was extracted from the original design. So let's go ahead and get that back out of the mask properties. So let's select OK, go back to assemblies, go over to reference sets, click on model, hold my shift key down, and then left mouse button click while I'm holding the shift key down to remove this interior volume body from the mask properties here. So we remove that from our model reference set, therefore it's not going to be part of the mask properties inside this design. So if we go back to File, Properties, update the mask properties, now we're right back down to our 30 pounds for our weight here. The next thing you want to do, you can maybe hide this, put this on a different layer. So I can right click on that and I can go ahead and just hide that if I want to, or I can go ahead and move that to another layer, call that layer maybe interior volume, something like that. All right, now that we have our extracted body, we have our measurement that was taken, both of these with fix at current timestamp turned off. Let's go ahead and make a quick change to our design here. So I'm going to go back up to the Home tab and we're going to go over to the offset command here for synchronous modeling. So I'm going to go ahead and pick this interior cylindrical wall and we'll offset that maybe 1/4 of a millimeter. So 0.25, sorry, 1/4 of an inch. This is in inches here. We'll hit our enter key, select OK. Once I do that, you can see my interior volume has decreased down to 305 cubic inches. If we go back to our feature tree, you can see the offset region is above the extracted body, delete face, and measure body because these were created with fix at current timestamp turned off, so they will always propagate to the bottom of the feature tree here. There's my offset region. If I right click on that and I suppress this, take a look at the volume measurement here once I do this. Now that goes right back up to 339 cubic inches here. So that's how you can create an extracted body that's going to represent the interior volume of your design, and then take a measurement to get the volume measurement on that part. And now these items are going to be considered live features. They will update according to any changes made to the original body inside your design. All right, jumping back over to our presentation here. The next item we're going to look at is NX Assembly's snap placement functionality with component interfaces here. So we're going to create some interfaces inside of our component parts. We're going to use the snap functionality with component interfaces to quickly place your components inside the assembly. So the question is there an easier way to quickly place components into the correct location and orientation inside my assembly? Yes, we can do that, and we can use interface objects with snap functionality to accomplish this goal. Now the process outline here, we're going to start out by creating a custom interface location on our components. We'll use objects such as datum coordinate systems, points, faces, etc. as our interface objects on that component, and these can be used as component anchors inside of the assemblies. Next step in the process, in our assembly add component dialog, we're going to use the save component interface, our component anchors, in combination with snap functionality to help place those components into the assembly. Now we can select the component anchor to use, set the assembly location to snap, and next we're going to locate the component by activating select object section of the location dialog, move our cursor into our graphics display to position the component. Once we move that component close to another component in the assembly, the snap functionality is going to take over, and it's going to use the component anchor to help place that or locate that in relation to those components. So we'll take a quick look at a demo here with the snap placement functionality in conjunction with the component interfaces. And we're going to take a look at the end of this assembly. So we do have a cover piece here. This cover piece is mounted on this cylindrical body here, and we have some bolts that are helping to fasten that in place. Let's go ahead and pretend that this bolt is not yet in the assembly, so I'm going to go ahead and hide that. And then we're going to go ahead and go up to the Assemblies tab, click on the Add Component option here. We want to select a part to add to our assembly. A quick tip here, I can go into the list and find the component I want to add, or I can go out here and open that by selecting the folder icon. But an easy way to do this, if your component is already loaded inside the assembly, we can click on one of the instances already inside the assembly to quickly select that. Now we're ready to add another copy of this or instance of that into the assembly. If you look in the loaded parts list here, it's highlighting the STS head bolt part. So quick little tip there. If you want to be able to easily select a component that's already added to the assembly and add another instance, just go ahead and click on that component. That's going to select that automatically in the list. Now we can go down and begin to place that and add that component to our assembly. We're going to focus on the location section next. So down in the location section here, the component anchor option, if we look at that and we hit the drop down here, that drop down arrow, you can see there's only one option right now, and that is the absolute option. So with the absolute option here, this is basically going to use the 000 absolute location inside the component part file as the anchor. What that means is if I come down here and I go to my select object category, left mouse button click on that, bring the item over, and of course I have the wrong part here, so let me go back over and deselect that connecting rod. I only want to pick the STS head bolt. So I'm going to pick on that head bolt part. I'm going to bring that back over. Now you can see that the anchor location for this particular component is at the 000 absolute location. That's the only anchor option we had there on the component anchor dropdown. So if I have my assembly location here set to snap, when I move my cursor over, you're going to see the software is going to use the information from that cover piece and look at that hole and the information from that hole, and it's going to help to snap this in place using the anchor location. Now the problem is, if I snap this bolt into that hole, the bolt is in the wrong location. It's not the ideal location here for placing that in my assembly. So I might want to go back over here and cancel this out and create a new component anchor location inside the component. So we'll go ahead and do that next. So I'm going to cancel this out. We're going to right click on this component and we're going to go ahead and open that up in its own window here. Now once we open up that bolt on its own window, of course you can see there's my work coordinate system. That's at absolute 000. And that was the only anchor location we had access to, and we wanted to add this inside of our assembly. We're going to go ahead and create another object here and create an interface with that object so we can use that as an anchor when we add this to our assembly. So the first thing we want to do here is go up to our Home tab, go to our datum plane dropdown, and we're going to create a coordinate system here. So I'm going to click on the datum coordinate system option. Now the datum coordinate system is going to start out, because this is set to dynamic, it's currently starting out at the center top of the bolt at absolute 000. The reference coordinate system here is set to absolute display part. So I can go ahead and use the handles here and reposition this if I need to. But I'm going to go ahead and click on, make sure I click on the origin there of the handle. And I'm going to come down to the edge of this arc. And you can see it's picking up on the center point of that arc, that circle. So I'm going to go ahead and left mouse button down and place the origin of my datum coordinate system at that location. Now another thing to remember here when you're setting up these datum coordinate systems to use as anchors, you want to make sure the Z vector direction is going towards the top of the part. This vector direction for my component anchor here is going to be important because it's going to help locate this in the hole in the correct orientation. So my Z axis is going up with my datum coordinate system. Now we're going to go to the assemblies, go over to the interpart links, and there's an option here called interface. We're going to go ahead and select that. On the product interface dialog box, for the interface type, you have a couple of different options. There's output, input, and then key performance interface. We want to create an output interface here. Next, we're going to go down and select the datum coordinate system as our object and create that interface location. With the coordinate system here, I can right click on that and I can go into interface properties and we can give that a descriptive name. So I'll backspace this out and we'll type in maybe bottom, center, bolt, head. All right, you can give a more descriptive description here if you want to do that, but I'm just going to go ahead and update the name there and then select OK. And now you can see my interface option or my interface object has a new name, bottom center bolt head. I'll go ahead and select OK. And let's jump back over to our assembly. Once we jump back into that assembly, we'll go back to the Assemblies tab, Add Component. On the Add Component dialog box, once again, the component that I want to add is another instance of this bolt. So I'll go ahead and pick that in the graphics display. We'll come down to our location category. For our component anchors, we'll hit the drop down here. And now you can see I have a new option. I have the bottom center bolt head component anchor location. So let's go ahead and select that. My assembly location is set to snap here. And now we want to make sure we activate the select object section of this dialog. So I'm going to left mouse button click in there. It has the orange background that is activated. Move my cursor over to the graphics display. Once I place that cursor in the graphics display, I get the preview of the part. And I can see where the new anchor location's at. That's at the bottom center of that bolt head. Now we can bring that over to the hole or bring it over to this cover piece, and it's going to snap right into the hole very nicely for me. Once I'm happy with the location, I can left mouse button click and place that inside my assembly. Once you place that, I want to be clear here, this is not going to create the assembly constraints automatically for the user here. You still have to go in and create the assembly constraints. A little tip here, once you have that located in the general location where it needs to be, you can make sure this is placement option here is set to move, grab the handle here and drag that away a little bit. And now I can go back into the constraint option here and then quickly create some constraints and apply those with my design. So if I set this to concentric, I can pick this top of that hole and make those concentric. If I set this back to touch align and grab that, I can see it can still rotate, but the part is in the correct location at this point in my assembly. Once we're ready to go ahead and finish the operation, I can select OK and finish adding my bolt to my assembly. All right, so that's creating these different interface points on your components and using those interface points to help you place this inside your assembly and locate that very quickly inside these assemblies by using the snap functionality. So that wraps up the NX Assemblies snap placement functionality with your component interfaces here. All right, thank you for watching. Up next, we have Hidden Gems in NX CAM, presented by my colleague, John Vincent.